Hello friends, welcome to engineering tutorial. So today we are going to resume our discussion on the basic physics, that topic, that basic introductory concepts related to physics. So far we have discussed some basic concepts related to scalars and vectors, and we have discussed a lot of things related to vectors, uh, resultant vectors, triangle law, parallelogram law, and a lot of other things. So you can please check the basic physics playlist to get all the videos. So today we are going to take our discussion forward related to vectors. So today we are going to discuss about resolution of vectors, or resolution of a vector in a plane. Okay. Now, so far what we have discussed is to find the resultant vector, the equivalent vector of two or more vectors. Suppose we have two vectors like this. Let's call it A vector and B vector. Then this will be the resultant vector. Then their magnitude and direction, everything we have discussed. Okay. The resolution of a vector in a plane, what it says is that if we do this thing in reverse, okay, let's say we have this vector, okay, we are given this vector, R vector. So we can split it, okay, we can split or divide this single vector into two or more vectors, so that when we join the head and tail of those multiple vectors, we get this resultant vector as the equivalent result. So like this, the same thing, we have just reversed the process. Here we were given A vector, B vector, R vector was the resultant which we got. Here we have R vector which is given, and we have divided it into two vectors, A vector and B vector, and their magnitude and direction is such that when we join the head and tail of A vector and B vector to get the resultant, we get this vector R which is given. Here these two vectors were given, A vector and V vector. This was the result. Here this is given, R vector, and we resolved A vector and B vector into two parts, R vector into two parts, so that we got this as result. So this process of splitting a single vector into two or more vectors, their magnitude and direction is such that their sum or the resultant gives us the original vector. So we can do it in different ways. Let's say we have like this a vector, okay, R vector. Similarly, we can resolve it into any way we want, like this, okay, this, then this, okay. This is, let's say, called A vector, this is B vector, this is C vector, like this. Let's say we have a vector like this. This is the single vector which is given. We can resolve it into, let's say, like this, 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 and then this. This is A vector, this is B vector, this is C vector, this is T vector, like that. In any way we can resolve it, but the condition is that the magnitude and the direction of the components, the splitted components should be such that finally they give this resultant, okay? That is the condition. So this is a very important concept which is utilized in various ways. We'll discuss it when their application comes. There are many fields where the concept of vectors are utilized: electromagnetic theory, mechanics. There are a lot of applications of this concept. We'll discuss it when we discuss that particular application. So this is the resolution of a vector in a plane. Again, resolution of a vector is splitting a single vector into multiple components vector. So here the single vector R, okay, here the single vector R is splitted into two component vectors, A vector plus B vector. Here the single vector R is splitted into three vectors, A vector plus B vector plus C vector. Here it is splitted into 4, A vector plus B vector plus C vector plus D vector. But here we did the opposite. We had two vectors, A vector and B vector, and their resultant was R vector, okay? Similarly, we could have done, like, suppose we are three vectors like this here. Okay, A vector, B vector, C vector. This is the result. Okay, so here there are two ways in which we can proceed. First, joining the head and tail of a number of vectors to get the resultant vector, or dividing any given vector or resolving, splitting any given vector into multiple component vectors. Both are useful, both have their own uses in in various fields for various types of analysis and all other things. So this is the basic concept.